Hi, guys.
Hey, everyone.
So I think it's time to start. There are still some people missing, but I hope they will join soon. So we will start with the SwiftUI Architectures workshop. The idea is to introduce you to some of to SwiftUI's architecture that we are basically we have worked with. And then the workshop is basically like a combination of theory and hands-on. So let's start. So I'm Nasir. I was born in Pakistan and I'm currently living in Munich. I am a senior mobile developer at QuickBird Studios, and I'm a husband and father of two, and these are my Twitter and GitHub handles. This is my colleague, Paul.
Hi, I'm born in Nuremberg, which is close to Munich, like 160 kilometers. I'm a Swift developer here at QuickBird Studios. I'm doing mostly iOS development and mostly with UIKit, but I've also worked personally and also for the company with SwiftUI. And besides my job at QuickBird Studios, I'm also a TUM master student in computer science. And here you can also see my Twitter and GitHub handles.
Okay. And we both work at QuickBird Studios. We are a group of young and passionate mobile developers who would like to take on really challenging apps, and we're really passionate not only about developing those apps, but also about the quality of the apps. And as we hear, our clients are really happy with our work. And yeah, we have different annual events like the Oktoberfest in Munich and also the Christmas dinner. Apart from that, we also conduct some workshops like on SwiftUI and all other of our frameworks. We have a few frameworks like X Coordinator and stuff like that. And we do before the pandemic, we had a session every 3 months. But now we have type of paused, but hopefully we can continue after the things get better. And apart from that, we also have a blog where you can expect a quality article, like one quality article every month. It's not like a normal or other blogs. Like we really choose the topic and do a lot of brainstorming and then come up with really good articles. So you can also check that out. So that is all about us and what we and our company do. Now it's time to have a quick introduction round. Since the number of participants is more than the number that is suitable for having a personal introduction. So what we would do is we would like to ask some questions, and then you can raise hands if you have done that.
Or we do it in Slack.
Or we can do it on Slack. But it's, I think we should decide on one. Maybe.
I'm on it.
Okay. Oh, we can start the Q&A here.
Which one?
So Paul will start with the first one on Slack. Just a few more seconds.
Okay. Now it should be visible to you.
Now you should see it. In Slack, in the channel. Okay.
I'm already adding the other messages as well.
Okay, just
so
a second.
We see that everybody has had first contact with SwiftUI so far. And now let's go to the second question.
Just don't forget to answer every question.
And with going live, we mean any application that has either been in enterprise distribution or on the App Store, for example, something that is actually in use by a lot of people.
Good.
Oh, sorry.
Next question is coming.
Yeah, sorry, I missed the poll. I'm sorry. Need to do something about what we will take from that.
Okay, just a second. Let's be done with the polls.
No.
You still have one right, left.
I think it's
two
two
left. Okay. I'm looking at the results of the poll.
Do you want to do something about them? I can scroll through.
Okay, so I think we have quite an audience who are experienced with SwiftUI. Can you go to up?
This one?
Yeah, okay, a lot. I think every one of you has worked on SwiftUI, at least at a first contact. A good number have created a SwiftUI views. That's nice. And yeah, we have a few who have live SwiftUI applications. That's really cool. And state management, yeah, a lot of you also have like experienced the issue that we could have with the state management. And yeah, the SwiftUI and struggles are really, I think, hand in hand with each other. And all of you also have experience with UIKit. Okay, perfect. So let's move to the next part. So this workshop is basically divided into theory and exercise parts. So during the theory, we feel free to write the questions in Slack, but like we wouldn't like to be interrupted during this part until it's really important, like maybe you're not hearing us or something like that. Or if you have really a question that cannot wait, but mostly like we have an exercise part where you can ask questions on Slack or Zoom. So it's like, and in that case, in that you will have a lot of time to ask questions. And the procedure is that you raise your hand on Zoom, and then we can basically unmute you, and then you can ask the question, and we can answer.
It's your turn. Yeah, I can do that as well. So we are basing this whole workshop on a QuickBird application that we built. And it's actually a GitHub client where you can log in with your normal GitHub account. And then you can see a view for your profile, like what your handle is and what's the information about you. And then you can also see a list of repositories and more information about each of those repositories. We will go into further detail about the application later on, but just so you keep in mind, we will build this application during this course. So first of all, we want to check how we can actually evaluate different architecture approaches, because we want to have a look at what kind of an architecture we use for our QuickBird application. And normally we would start with something like the solid principles. For example, the solid principles say that a type should only have a single responsibility, it should be open for extension but closed for modification, and many more principles like that. However, we are not focusing on how we are actually building code, but instead we want a more broader look over the whole application, and we want to actually see what are the benefits, or what kind of metric we can take for a good architecture, depending on the actual problem for a specific app. So what we mean by that is we actually want something like, for example, we want to reduce code overhead. We don't want to write repeated code, which is not really serving a well-defined purpose. For example, all of this boilerplate code that you need to write for certain architectures. We only want to write as much code as is actually needed, and in case we add like code overhead, it must actually serve as a justifiable cause. Like we need to have a benefit from this code overhead. So by reducing code overhead, we actually have the benefit of decreased development time, because we don't need to develop that long if we don't need to write unnecessary code, and we can focus on more important tasks. However, often code overhead might also bring in some benefits as well, because we can have a better abstraction that might lead to fewer problems afterwards, because we've already abstracted some parts and stuff like that. And then we also have a meme about that. And yeah, so we should actually reduce code overhead. However, in some cases, it might suit our problem as well. Let's continue with testability. We actually want to be able to test code easily, both individually, like we want to, for example, test individual views or individual components of our architecture. And we also want to test our whole app. For example, if you take a look at SwiftUI, we want to be able to preview every individual part of our application, for example. We also want to be able to mock certain functionalities of the application, since one part of the application might not be ready yet, but we have some mock data that we can show already. Then we can, for example, for a customer that we are consulting for that application, we can then already show the UI in action without actually having the business logic implemented. We also want to make sure that everything works correctly, so that's also a benefit of testability. With an increased testability, we can identify bugs early, and as I already said, we can mock easily, for example, for a demonstration. However, it increases the development time, it makes the whole project probably more complex, because we are doing more abstractions and possibly allowing for example, a mock implementation and stuff like that. And we also have an increased code overhead, because, for example, we may want to write a protocol for a specific service to then allow for different implementations of that service, depending on whether we are mocking parts of the application. And of course, testability is also not always the required. So yeah, just keep that in mind, that testing your code a lot might also take a lot of time. Going to the next one that is actually important for SwiftUI in general, because SwiftUI is based on a strong concept of the state. So we want to keep that state consistent throughout the whole app. We want to always show the user the current model state, and make sure that that state is actually consistent with what, for example, we have in our database, or with what the user did in some, for example, if we have a screen where there's multiple input fields, then we want to make sure that it's consistent what is shown to the user and the data that he's then, for example, sending to some server or something like that. The information shown to the user should also not contradict itself. Like there should not be one label stating that that some value is higher than it's written somewhere else, but instead if one value is used throughout the app, then it should be updated everywhere. And yes, and we need to make sure that state changes don't contradict itself. We want to keep memory usage minimal, so we possibly also want to store the state only at one point and not at multiple places in this throughout the app. And we need to make sure that the view set is actually updated. from that, we gain a great user experience. We get less errors, possibly. However, we also it can also lead to increased coupling because we have one state that is then, for example, shared throughout a greater part of your application, and there you possibly create some dependencies that you're not aware of. And it might also lead to error propagation. For example, if you're setting the state at one point incorrectly, then it might lead to problems in a completely different part of your application if that state is shared throughout a big portion of your application. Yes. So continuing with code consistency, we just noticed over the years that we want to write consistent code that looks similar throughout the whole application, so that when you go to a screen, for example, of your application that you haven't worked on already, however, it looks similar to the ones that you've already worked on, then it's quite easy to get the whole structure and to know where to look for certain problems or where to add a new feature. So we want to have common abstractions for similar abstraction cases. For example, if you have similar screens, then the screen should actually also be be similarly structured. So you want the same structure for similar views, essentially. And finding the right abstraction to fit most problems is pretty hard. However, we try to find abstractions that work for a lot of applications. From that, we benefit a reduced maintenance cost because you can easily find where to look for the part of the code where you want to add that functionality. And we also get a reduced learning curve for existing developers because you already know the structure of the whole application, and then you can easily go to a new place of that application, to a new component, and easily figure out how it's actually working. However, there's a downside as well. There's a higher learning curve for new developers because you need to actually learn that structure and get familiar with it. And the consistent solution might not be the best solution. So, for example, sometimes it might make more sense to write it in a different style. And then the team, for example, might force you to do some kind of a consistent style throughout the whole application, which might not be the best solution for that problem. So yeah, continuing with the next one, if we are building an application if you're building an application where you need, where you want to move views from one part of the app to the other, like just in the user interface, then we want to be able to move it easily because, for example, a customer or someone else might want to change the user interface completely, and we might want to reuse a view in a different spot of the application. And there, we just want to be able to move a view from one part to the other. And we also want to make sure to keep dependencies to other individual parts of the application small. For example, we don't want to rely on the type of our parent view or parts of the state of another view and stuff like that. As a benefit, we get, again, reduced maintenance cost for when we change the UI a lot, even though the general application is not changing that much. And we get decreased coupling to individual parts of the application because when we are focusing on having that flexibility in the app, then we also have decreased coupling. However, we have increased coupling to the whole application because we possibly then have some state which is available to more parts of the application, and then we have further problems. Of course, you have to keep in mind that those metrics are only part of what we think is great for an application, and they are often also contradicting each other. So keep that in mind, and for your problem, for your concrete application, it might differ a lot which metric you prioritize or which one is even not valid for your application. So another metric would also be flexibility across apps. So we want to take one view, for example, and just put it in a different app because we already implemented a login screen, for example, and we only need to make minor changes to, for example, we want to show a different logo on the login screen, and then we can just copy one view from one application to the other one and easily reuse parts of the application. That's what might be useful. For example, in case you are building like quite abstract or generic views in general. From that, you get a reduced development time again, because you can easily reuse views across apps. They are less error prone because they already worked in the previous environment, so they probably work all right without much testing needed. And reuse is rarely actually needed for the complex views, since they are so specialized. So actually focusing on this flexibility across apps might not be useful for all of the views. For example, one view might be super specialized on this GitHub application, and then it doesn't make sense to reuse this view in a different context, in a different application. Then the next one, I'm almost finished. The next metric would be modularity. So in general, we want low coupling and high cohesion. In case you're not familiar with that, with those terms, we want code that is doing similar operations. For example, we want code that is doing network requests to be in one component of our application, and we want code that is doing, for example, view related, like only which is deciding the user interface. We want that to be connected. However, we want some kind of a difference between what, for example, what operations the application really does and what the user interface looks like, because those are different operations, so they should probably not be at the same place. However, we do not want to overdo it, because modularity can also be quite bad if you overdo it. So yes, just keep that in mind. And it's easy to find code related to a specific topic for existing developers. For example, if you have made a modular architecture in your whole application, then a developer might easily find where to look for in case there's a problem with setting user defaults, or in case there's a problem with network connections and something like that. However, there's a steeper learning curve for new developers, because they actually need to find out where in that architecture there's a lot of where to look for certain operations. For example, it might not be obvious that network connections are abstracted in some module, and then they might be looking throughout the whole application to actually find where the erroneous code is looking, is actually in the application. However, it's also less error prone. So yes, as I already said, you can do over modularization, and that's a real thing. So just keep that in mind too. We need to find some kind of a compromise between modularity and the next one, which is code proximity. So we want code that is connected to a specific feature, for example, some action that is happening because of a button, for example, in the application. We want to easily figure out what that action is doing, and what are the causes for certain problems. So we want code that is related to a specific feature, or for example, to that view component quite close, and we want to actually figure out what's the problem with certain things. And if we over-modularize, then we can easily get the problem of not finding the code that is actually causing the problem, since we need to, in our head, we need to open like 20 different files because we need to find the path where the code is actually going to and where the problem then actually exists. A benefit from that is it's easy to find code related to a specific feature and its direct consequences. However, for example, if you're writing network code, then inside of your view, which is probably a little bit too high of a code proximity, then swapping out a dependency or swapping out certain functionality is super hard, because you have to keep in mind that that code might be in a lot of other places in your application as well. So you don't have that abstraction. And it's more error prone for consistency and compatibility issues, which is essentially a similar thing. So in case you discover a bug in one of those cases, then you can't change it for all of the cases, but instead you need to figure out where similar code is written as well and change that as well. Yeah, so for example, if you put data access code in throughout the whole application, then you will probably never get rid of it. However, if you have it modularized in a separate component, then you will probably easily be able to just swap out that whole component and change its implementation, or figure out a bug that is being caused by one of those methods and change it for a lot of cases that you might not even have found otherwise. We want to go into a somewhat open discussion here with you. So what other metrics would you also consider? What is most important to you, and when do you want to focus on which kind of a metric? So feel free to raise your hand if you want to say something, or if you have already made up your mind. And we will then, in 10 minutes, we will continue with the rest of the session. Yeah, but it was slowed. Yeah. Is there anyone that already made up their mind or wants to say something about those metrics and what you want to consider as well, or what you think is also important? Okay, Rob, it's your turn.
Hopefully this comes through. I really love where you're going with these metrics, by the way. These are fantastic. Okay. The other one that I found particularly in the iOS world is, and the Apple world more generally, is thoughts of how Apple is going to change things. So a really common thing I see are really elaborate architectures that then get completely blown up because they kind of ignore everything Apple told us to do. And so I hate, Apple's stupid, they don't know what they're doing, I'm just going to hand do all this stuff, and then blam, because Apple then brings out storyboards or auto layout or whatever.
Okay, do you have any other metric to add to the list, or which one is like most important to you, and stuff like that? Do you have anything else to say?
Well, I really loved early on you had, probably the most important to me was that you don't create a whole bunch of things you don't need yet. That was probably the biggest one I found. I don't like any architecture that makes me create 3 different objects as the starting point where you even get started. I think is probably a bad idea, and hasn't. I've seen it work well until you're 3 years into the project. I think a lot of when you're thinking about these in metrics is like, how is this going to age 4 years from now?
Yeah, that's true. That's
other than that, I love the list. I love it.
Okay. does anyone else want to add something to the list? Is it disabled?
No, allowed to talk.
Hi, Chris.
Hi, y'all. How are y'all doing? The one thing that popped up for me, and this just goes back from when I was onboarding at my current position, is code readability. It's hard to jump into a project that you haven't been in before, and it's huge, and you're a little overwhelmed anyway because you're in a new position. But just being able to look at a file and read through it and just kind of piece together what you think's going on versus, okay, I need to go look at these 5 other files to find out what's going on just inside of this one file. To me, that's a metric I think maybe gets glossed over, and it's, even though I'm I'm responsible for this particular app or whatever, when I'm writing new code, I'm always trying to think about, well, if I leave here in a couple of years and somebody takes over, are they going to curse me, or are they going to say, man, this guy really left us in a better position than maybe somebody else might have? And so that's a metric that I personally just think about a lot.
By the way, just so everybody knows, we are noting down the different metrics that you are telling us as well. And in the end, for the architectures that we are going to present, we will also include those metrics later on and have a discussion then about which architecture makes the most sense, and for individual problems, of course. Yes. Okay. Does anyone else want to add something to the list? We still have some time left. Okay. Yeah. Right. Hi, Hendrik.
Hey. One possible metric would be performance, which I don't think you addressed, which is not like the most important for UI code generally, but still something that I think is, especially these days, like, where the phones are or the devices are so powerful, but it's still something to keep in mind. Like, so if code gets like repeatedly executed or is like really not performant.
We have considered that before as well, but we've then removed it from the list actually, because we found it quite difficult to evaluate for the different architectures that we are proposing today, especially because we try to, whenever we have a shared state, we try to actually use that shared state as well. So I don't think performance is that big of an issue in those cases. However, we will also include it in the list in the end. So thank you for the addition of that.
Anybody else? Okay, Rob again.
Will you want me?
Yeah. Hi.
Rob, you wanted to say something as well?
Rob, we cannot hear you.
Apparently there's some technical difficulties. I'm trying to mute him again and then unmute him. No. Rob. Okay. Yeah. Is there anyone that wants to add something to the list or something that you would like to say about?
Hi, Ben.
Hey guys, thanks for putting this on today, and good thoughts all around. This is more like a bigger picture thought, but a lot of the apps and experiences I work with, they're going to exist on other platforms, and one of the things that I find often that I need to keep in the back of my mind as we're building anything is, should the back end be deciding this instead of deciding a bunch of complicated logic or implementing a bunch of architecture and then having to re-implement that architecture on, say, Android or another platform. So sometimes we have to sit down and say, should this code be pushed somewhere else? Because even UI decisions or things like that might have a couple of values that need to be strung together, it could be better there. I just want, yeah, Rob put it perfectly: smart server, dumb client, because then I'm also going to be fast on the client.
Mm-hmm. That's true.
We still have time, right?
Theoretically, yeah.
We still have a few minutes. Anybody else wants to add something?
Otherwise, we will just continue with our application.
Let's wait a few seconds.
About would it be possible to have the camera on the speaker? We are changing the speaker all the time, and we don't want to change the microphone and stuff like that all the time. So if you want, you can just pin it on the speaker that is talking at that moment. Otherwise, you will see Nazir for the next few minutes anyways. So yeah, we will try to make it possible for the future.
I think we can just switch the MacBooks.
Yep.
Okay, I think we have some other questions. No, right?
No, let's continue.
Okay, so I think let's continue.
Yes. So for the next 2 slides, I'm still saying something, but otherwise, then I'm handing over to Nazir.
Just unmute yourself.
Yeah. Can you turn down? So I hope you can hear me now. So in general, you can think of SwiftUI as a function. For example, the body of a view is essentially the function of the state, which is then returning some user interface. So I just want to get that idea into your head. So in general, whenever we change the state, then the body is re-evaluated and we get a different user interface. So we might change a certain number in the UI, but we also might trigger, for example, a transition or something like that, because we have changed the state in some form. And for that state change to actually re-evaluate the user interface, we need to wrap that state in, for example, the addState property wrapper, the addBinding property wrapper, or the addPublish property wrapper when we have an observable object. So let me just explain those terms to you. So we start with the addState property wrapper. It has stored view state, which is owned by the view that is specifying that variable. In contrast to that, the binding property wrapper is the combination of a getter and setter in general. However, it's most of the time it's used to access a property that is wrapped in the addState property wrapper, but is then used in a different view. For example, you might have a binding in a text field where you want to have the binding for the information that is in the text, and so the text field can actually change the state of the view that is that has that text field as its subview. And whenever you change if you change some property that is wrapped in a binding, then you also get view updates. Then there's the observable object protocol. It's a protocol that can be implemented by, for example, a view model or some other class, essentially. And in there, you're using, for that observable object, you're using an addObserved property wrapper. And there you can just implement some class with multiple properties that are then wrapped in this addPublished property wrapper. In case you're not familiar with those terms, please remind us about that in the next exercise so that we can explain those terms again. Since we are not entirely sure if you're too familiar with those terms in SwiftUI then. Because most of the tutorials focus on the first two parts, and we are focusing mostly on observable object and observed object. So in general, you can just think about that you're creating some class which implements the observable object property protocol, and you are then wrapping it in the observed object property wrapper. And we will show you that in the next exercise. And then whenever one of those properties changes, then the view is also changed. Besides observed object, there's also environment object, but essentially those two don't differ that much because observed object and environment object can be used in the same cases. But in one case, in the environment object case, the class is actually extracted from the environment, and in the other case, it's stated in the initializer of that view. So in one case, you just extract it from the environment, and you don't need your parent to know about that dependency that you have. And in the other case, you specifically say, give me that observable object. Yes, so I will hand over to Nazir to talk about the model view architecture and how we build the QuickBird application.
Okay, so let's start with the model view. We call it the model view because like SwiftUI has a view and then we are basically adding a model in there. It's like, I think you would have seen this type of code in all the tutorials that you normally find on the internet. This is, I would say, like the basic or the first hand way that people write the SwiftUI code. So we have basically a view which fetches data from the model, and it also basically subscribes to the model state changes. It can also like perform events on the model, maybe change the state of the model or perform some other action. And I think this is the easiest way and maybe the very fast way to start bootstrapping of anything. Like you can easily and quickly create a view within no time.
Just a thing to add, we are, in this case, we are not talking about a view model, but instead we are actually talking about the services and the different components that you're using in the model of your application, like that make up all of the logic of your application.
So let's introduce the application. The application has basically 5 distinct views. The login view, which is used for logging to GitHub. The authentication view is basically a web view where we basically pass the control to GitHub to do the authentication part and then return the success or the result to us. Then there is a profile view where we show basic information like the number of repositories, the followers, and where you live, and what's like which other accounts or companies you are linked to. Then there is the repository view, which basically lists all of your public repositories that you have, your own or the repositories that were forked. And then the last one is the repository view, which basically shows you different information such as about the repo, like the description, the summary, the contributors, even the languages, and pull requests, stuff like that. So this was a quick intro to the application. This is more like for the purpose of finding things so that you can easily find the things in the app, how the app is structured. I wouldn't like go, I would quickly go through it that we have a content view, the default naming, that which has a login view or a home view based, if you're logged in already, you see the home view, otherwise you see the login view. And then you can use this authentication, like once you click on the login button, you are taken to the authentication view. But if you're logged in already, you can see a profile view, the settings view, and it's now called a repository list. Previously, it was called main view, so it's like repository list. And from repository list, you can click on any repo, and then you can go to the repository view. So this is like more of a quick way of finding where the different code is, so the findability of the code.
It's for you as a reference.
It's as a reference, so that once you are working on it, you have an idea, rough idea where to jump to find some specific stuff. At the moment, the settings view is more like a really basic view. It is just a label in there, so but all others are full-fledged views. And just a sample implementation of how like any view will look like. This is, so maybe I just skip through it. So for example, we have a user who has a list of repositories, and then we show that as in a list, and we also like fetch those repositories whenever the view appear.
You can go through the application. You can just
yeah. So let's quickly go through like the application. I would like to just quickly go through and introduce you. Maybe let's have first a run of this. I will have to share the different screen. Just a second. Okay. So now you should be seeing my Xcode. Let's just quickly run through the application and see how those views or how the flow looks like. So this is the profile view. Maybe let's just.
See this.
Sorry. Then let's share the simulator. So this is the login view that you see. Clicking on it basically takes you to authentication view, where you basically put your GitHub username and password. Signing in, and then you are redirected to the profile view, which is basically the main view of this tab bar. And then you can also go click here and go to my profile on web. Let's go back. And here, if you go to the main view, you can see a list of my repositories. And then maybe clicking on this basically tells you like the languages, the contributors, and things like that. Maybe let's check another one, maybe this one. So basically, this is just a list of my repos that I have made public. And you can see different information about that. And then, as I said, the settings view is really just like the basic settings view with just label. Okay, so maybe
later on, we just thought that maybe in some exercise you would like to explore new parts of that application and maybe try something out. So we already added a view where you can then try out things or add your own information.
Yeah, and just we can have a quick go through over this. So this is the content view, which basically checks which view to show. And we are basically like, for simplicity, we are calling methods on appear. You can also follow a different approach, but this is what we decided to take. And then the login view is just like enables you to log into the GitHub using your GitHub credentials. Then we have the home view, which is basically a tab view, 3 tabs, and the default one is the profile. So as you know that like it's basically a function of the state. So whenever I change the selection, like unlike UIKit, changing the selection, like in UIKit, you have to do everything yourself. Okay, show this view and things like that. But in SwiftUI, you change the selection, and then since you change the state of the view, it should basically re-render and show you the right screen. And other than that, the repository list, which shows you just a list of repos. It like we always basically do whenever the view appears, we try to load stuff, and then the view that you saw where we had like the contributors and stuff, it's like more like a composite view, having more views embedded inside it, like the contributors, languages, and pull request. You can add more views in there. as like things that GitHub API provides. And then the last one is like the placeholder view for settings. So let's get back to the presentation. Okay, this one. So yeah, this was just a quick go through to the application. And now, as we said, that it's a hands-on, so you have like 20 minutes to clone the repo, check it out, maybe change some code, maybe write some other small view in there, maybe like do just type of play with the code and try to get yourself familiarized with the code, or maybe add new features so that you are warmed up for the next part of this workshop.
We will then take a look at a different architecture and then change the example app. So we now want to give you the possibility to just check it out and figure out how it's working from the current state on.
Yeah, and we are also open to questions now if anybody wants to ask something.
So did anyone already face any issues? Did you already try the application? Did you already run it and stuff like that? So in case you face any problems, just write on Slack or in Zoom or wherever you prefer. Okay, so we would like to continue with the presentation. I hope you all found like into the app and you're already familiarized with most of the parts of the application. Now we want to have a look at what the current architecture that we use now, which we are calling model view architecture, how that compares to the different metrics that we set up before. So code proximity is quite high because you can pretty much see what is actually happening in the model whenever you have some kind of an action, because in your button, for example, at the login view, you can immediately see that on a peer calls this method and it's in the same file, and in that same file the actual action on the model is also performed. So there's no kind of abstraction between the view and the model. So you immediately see what kind of an action is performed on the model. Then also here we added performance before. We just forgot to remove it because in the model view architecture, actually performance quite depends on how you implement the model view architecture. In one way, you don't really have to in one way you don't really have to have any like change of the action that you send from the view into the actual operation on the model. However, performance is pretty bad if you think of that you're getting the same state in different views from the model, and you don't really have a shared state that you can access that data from. So then performance would be pretty bad. There's very little code overhead, assuming that you have all of the model services and stuff like that abstracted well enough, then you pretty much have no code overhead that is apparent to the architecture itself. Yes. Then there is, then we have this yellowish part, which means that there are positive sides, but there are also negative sides depending on the specific situation. So flexibility inside your app, so moving the view from one part of your app into another, is medium, because in some ways you can easily put the view somewhere else. However, if you rely on some model services that you then need to push through like 4 different views or something like that, or rely on an environment object being set or something like that, then the flexibility inside the app starts to crumble a little bit. Then testability, it really depends on what you define as testability and what parts of your application you want to test. Because if you want to test the business logic of the view without actually showing the view or without writing a UI test, for example, it's quite hard to do in those situations, because of course you can test your model, but you cannot easily just send out an action for that application and then see how the UI reacts to that change in state. Then flexibility across apps is also medium, because in your view you actually have dependencies to your model now. So you, for example, specify the login service or the GitHub service, and that means that you cannot easily move that view to a different app without actually making sure that that service also exists there. Then for the red part, there's modularity is quite bad, because you don't have this separation of concerns and this like where you are actually separating what is happening in the model to what the view should do. For example, in the next architecture, we are going to see that it's possible that in your view, there's you do not actually specify what is changed on the model depending on different actions. However, you are simply saying that one action that you defined should be performed, and then a different component decides what is actually happening because of that action. So for state consistency, it's also quite bad because you do not really have a shared state except for when you're using binding. However, you have to think about that you cannot easily use a lot like bindings across the whole app for different models. For example, in one view that might be somewhat complex, you might then have like 5 or 10 bindings, and then it becomes quite hard to actually build a view out of that and to create it using the initializer and stuff like that, because that gets quite crowded once you have a lot of shared state that is not abstracted away in some other class or some other object. Then code consistency is also quite bad because the different views might look completely different and might for example, might not be ordered correctly. For example, of course, you can define some kind of a style for those views. You can, for example, say that all of the actions need to be in a marked section of that view or something similar to that. However, it's quite hard to actually create consistency in all of those cases instead of just creating that code consistency by the architecture itself. Okay, now we want to abstract a bit. We want to take that application that we have already, and we want to implement a Redux-like architecture. I will explain Redux first, and then we will have a look at how we will implement it in the application. So first of all, why are we actually doing that, or what is the general idea of what we are doing? We are trying to remove this business logic, all of this calling of the model code, which might not look like a lot at the moment, for example, because you could abstract all of that logic into, for example, a different service or something else that acts like a view model but doesn't really have state or something like that. However, we are in this workshop, we are trying now to get rid of that business logic from the views and actually only defining the user interface inside of the views and not care about this business logic part. And we also want the possibility to change the business logic for another use case of the same UI. So whenever we want to use, for example, a view and we want to put it into a different app, then we want to be able to reuse this whole UI code without actually changing the UI or without actually changing the view code itself, but we simply want to inject a different component that then performs the business logic for that application. For example, we might use a different service, not the GitHub service, but for a different application. We might then still want to reuse the login view because it also has an OAuth login, and it also provides similar login services. Exactly. Then we have to take some considerations for the abstraction of the business logic in SwiftUI. One case that we found out like most frustrating is that whenever you're using the addObserved property wrapper, you cannot specify a protocol. You're always bound to a specific class, for example. And yeah, because the generic attribute of the observed object property wrapper is constrained to some other protocol. That's why you cannot really specify a protocol there. Just keep that in mind for now. But otherwise, we would have preferred to just use a protocol for a view model or some kind of a store in a Redux-like architecture. In our case now, we will define types for an input and a state. The input being some kind of an action that should be performed, and the state being the state of the application at that moment. So in combination with generics, we will then use one view with different business logic without any code changes, but you will figure that out later on. And just keep that in mind, that maybe some parts might be like over-engineered or super generic, but they actually serve the purpose that you can, that you're not bound to that specific class that you are trying to implement, or, but instead that you can put in some other business logic as well. If you have some architecture already built, or if you have a different approach in Swift, then feel free to share your solution with the group, because I would actually be super interested in whether there are better ways of solving those problems in code. Yes, and maybe they will help others as well. So win-win. So let's have a look at what a Redux-like architecture looks like. First, we introduce essentially a store in between the model and the view. So whenever the view can access the view data from the store, and it triggers actions based on the user input. Those arrows are the wrong side, by the way. So the view accesses the data from the store, but it triggers also the actions on the store, and it then changes the model data and updates the view again whenever there's a change. So let's dive a little bit deeper into that part. First, we have the view, and we define some store that is used throughout the whole app. We just inject it as an observed object, and that store has a reducer, and that reducer is using the model to do some changes, and then updates the state of the store. So let's go through one of those actions, essentially. First of all, the store is providing a state to the view. And now, for example, a button was pressed. So the view sends an action to the store. The store then tells its reducer that action was performed, and the reducer then is deciding what model action is being performed. So the reducer essentially uses the model then to, for example, log in the user, and then it changes the state of the store to update the view again. So let's now see, okay, we have this updated store, and the view gets re-rendered. I would like to give you a little hands-on now with this QuickBird application. First, we will create the app state, the app action, which is essentially the state of the whole application. Then the different actions that are possible, and the app reducer, like that component that is taking the actions and the current state, and then deciding on how to change the state based on that action. We will then inject that store into the initial view. But for example, in the beginning, we will only build that for the login flow, like the login scenes. And then you will actually build the whole application using that architecture pattern. So as the first step, we will then inject the store into the initial view and adapt the initial view to actually use that store. So we will just remove that code that is doing business logic outside of the views and moving it to the store then. So so you should now be able to see my Xcode application again. And first of all, we will need to add two different files into Xcode that I prepared earlier. I will explain them in a second, but just keep that in mind for now, that we are adding a file to Xcode. After that part, you will be able to get, again, the code that I wrote right now, or something that I prepared earlier, but similar things. Do you have a second? It's not in there. Okay, there was a small technical difficulty, but we are good to go. So we will start. Let's just comment that code out for now. We will focus on the app action for now. In case you have already seen the application, like you have already familiarized with the application. So for now, we create an enum called app action, which provides us with all of the different action types that are used throughout the login part. And you will then later on add different other cases for all of the other actions that are also possible with the application. However, we first want to only build a first part for that. Let me just quickly change that. So for this for this application for now, we only have the option to do a stored login, which is essentially whenever the app is opened, then we want the login service to log in using the stored information on the device. And if that's possible, then it should just log in the user automatically. And in case it's not doing it, then it should just ignore it and let the user log in using their credentials. In the case where the user then entered the credentials, we have this login action with a specific code. That's the code that we got from the authentication service of GitHub. And there's also an action called logout. Whenever the user clicks on logout in the profile view, then it should perform this app action logout. So let's continue with the app state. We are defining the app state as just having the GitHub service and a computer property that is logged in, which checks whether that GitHub service is nil or not. For now, we don't really add a lot of state. You will then add a lot of state later on, but just keep in mind that whatever we are trying to put whatever state we have throughout the different views inside of this app state so that we can access it from all over the application. This might be useful. For example, this GitHub service is used throughout the whole app, so we can just use it from there. In the end, we are still trying to get rid of that GitHub service altogether and just have the information whether the user is logged in, because that GitHub service is again some dependency to the model that we want to actually get rid of. And since our view should actually only be knowledgeable of the state of the application and not specific model services. Okay. So now let's continue with some part of the generic implementation. We already added some generic code. You will also get that code in the next exercise. But let me go through what a store looks like for now. So a store has a specific state and a reducer. And whenever it gets a specific action, then it reduces, like it calls the reduce function on the reducer. I will go over that, what the reducer is doing in a second. It takes the current state and the action that was performed, and it then performs that action after the reducer has decided what kind of state change is about to happen. Whenever you want to create a store, you give it an initial state and the reducer that is actually transforming the different actions into state changes. So let's have a look at what a reducer looks like. The reducer has a state and an action again, and it essentially is only kind of a closure where you give in the current state and the action being performed, and it returns you a publisher of a state change. And that change is essentially a closure that says how you want to change that state. So let's have a look at how to implement such a reducer or how to define such a reducer. We are going back to the store plus apps.swift file. And in here, I've already prepared some code. So for that reducer, we are using the login service. In our case, the default login service. However, if you, for example, don't have a GitHub account, you can also use the mock login service. And with that mock login service, you will, however, need to make sure that you are then also using the mock GitHub service that we will create in a second, because otherwise you will get a lot of authentication errors. Because the login service, whenever you're logging in, the login service just gives you a success of that of your login, whatever it actually does. Yes. So let's go to the implementation of that reducer. We again have the state and the action, and depending on the state and the action, we want to define what kind of a model change we want to do. In this case, we just do a switch case with the different actions. For example, you could also define this action not as an enum but as a struct or something, and then you could do different other things here. But a switch makes, in this small example, makes most sense. But you are free to change it later on as well. So in our case, for the stored login, for example, the login service provides a stored login function already. And if we take a look at its implementation, it returns at any publisher that gives us login information and an error if there's anything that didn't go as planned. So in our case, whenever it worked well, then we actually want a state change, which this change here means. And we want to change from our app state that I defined up here. I want to actually set the GitHub service to the default GitHub service with that login information, so that we then get all of the information that is necessary for the login. The same case is for logging in with a specific code. So that's again the case when a user logs in with their credentials on the web view, and then we also want to create a GitHub service. For the case of a logout, we want to call the logout function on the login service because it stores the current token. And we actually want to get rid of the token, and we then also want to set that GitHub service to nil, so that again the view is updated and the application actually knows that you are logged out now. So now, as we've essentially implemented the whole business logic already, let's now have a look at how we can use that throughout our application in the views. So first of all, we want to have a look at the content view, and in here, that's the view that is created in the scene delegate. So in here, we want to create an add observed object of that store, which is a store app action app state, but it's the other way around. Yes, so in here we define our store of that app state and app action, and because I don't want to write this all the time, I actually want to create a type alias for it, and I'm calling it app store. I know it's a bad name, but for now it works. So whenever I write app store, I actually mean the store of that app state and the app action. So with our implementation, you are easily able to just use your own state and your own action. Yes. So feel free to just also copy this into projects where you want to use that architecture. Yes, so we already added it here, and now if we try to build, then it actually says that it's missing whenever we are creating that view. So let's create that store as well. and we give it an initial state of where the GitHub service is nil, which is essentially just calling init on it. And in here, we can just use the app reducer that we just created. And for the login, for the content view, we are now specifying the store as well here as a parameter in the initializer. So now it builds again. However, it's still not using any of that functionality that we added here. So let's now make sure that we actually use that store instead of all of the model view architecture that we added before. So first of all, we are removing all of the references to the login service, for example, because we've already handled all of the login service connections in the actions that we added to the store. So now we get a lot of problems with the different views that we want to create. And in here, for example, you see the first change that we do on the model inside our view. So instead of handling this whole logic on the model in our view, we instead want to just do store.send, which is sending that action to the store. Then again, the reducer is performing some action, and it's then changing the state of our application. And in here, we just want to try a stored login, so we are sending the stored login action. Okay, let's now have a look at how we can change the login view and the home view to also use that store. Let's first have a look at the login view. And in here, we see that we have a binding for the information, which is the login information. We don't need that. And we also don't need the login service. And we actually also do not do any combine activities anymore, because we will remove all of the model activities. So we don't need that property either. And now let's also create that observed object var store app store. And as we can see, it now gives us a problem in this login code method, where we are now sending the login code action instead. Okay. So now if we go back to our login view, we can create that login view with only our store that we already have in that view. And now let's go to our home view, because in our home view, we actually also have references to that login information, because with the profile view, we can get rid of that login information because we want to log out at some point. So let's add the store here as well. Get rid of this part and get also rid of the login service. And because we get the GitHub service now from the store as well, we can get rid of that property here as well. And yes, the profile view, we need to adapt as well. The repository list uses a GitHub service. However, we now can simply use it from the store, and now it's an optional. We are force unwrapping it here for now, which is obviously not the best idea, but we are only showing that view whenever that GitHub service is available. So for now, it's fine. In the exercise, you can actually try to get rid of this exclamation point, or you can, which is actually the intended idea, and you can actually get rid of that GitHub services completely and instead use the store and handle your cases in there. So let's take a look at the profile view and how it's actually handling the logout functionality. Let's first add our store here as well. Let's get rid of the login service and the GitHub service. And here we need to specify again, the GitHub service out of the state. It's now called GitHub service with a lowercase h, yes. And if we scroll down, at some point we here get the logout functionality with the login service and the login information set to nil. So in here, we again want to send an action, which is the logout action. Okay, let's have a look at how we need to adapt those views. In here, we only need to add the store. And let me have a look. Okay, and for the profile view, we also need to figure out how we can create that one. And we only need the store to create it. So let's get rid of this complicated initializer and instead just eject the store. And now, as we can see in the scene delegate, we need to remove that login service because we've already used it in the reducer. And now it builds fine. So let's run the application once and check out whether we have any issues. Let me just share a different part of the screen to show you the simulator. So we will just log in for a second and then we will be right back. Okay, so as you have seen, this has not worked yet. So I've probably made some kind of mistake. And the mistake that I've made is that I still have some state which is not controlled by the store. And let me get back to Xcode to show you how we can change that. Okay, so let's go into the content view. And in here we see this when construct. And this when construct actually says when we have some login information. And actually I just forgot to remove those two. When we have this login information, then we want to show the home view. However, we need to adapt that logic as well. So we are just using a group here. Or actually, I'm not using a group. I'm using this when construct again. Because there's also a when condition. You can just copy that from our application. In general, it's just a group with an if inside that is either showing that one view or the other. So in here, we are saying when the store is logged in, then we want to show that home view. And we actually can just copy it from here. Then we want to show the home view, and otherwise we want to show the login view. Essentially, that's just the logic that we want to have. So whenever the store is logged in, then we want to show the home view, and else we want to show the login view. So let's again run it on the simulator. I will change to the simulator. And now we can see that we are logged in, but let's log out once again. And Nazir will log in again. Okay. And now, as we can see, the login works perfectly fine and everything is working as expected. So let's continue to this. Let's get back to the slides. And then I can tell you how we will continue with this Redux integration into our app, because we now want you to extend the Redux implementation to the rest of the application. And please, again, as you have already cloned that repository, but please check out the Redux start branch. And from there, you get the state that I'm currently in with the application, and you can then further the Redux implementation to all of the other screens of the application, or just take a look at how that Redux implementation works and how you may be using it in different views or in your own projects. Maybe just take a look at the different at the implementation that is already there and what you can do out of it, and we are interested to see what you can do with it. So again, let's take another 20 minutes to get you started with Redux in that application. If you happen to have any questions, feel free to just ask them on Slack or in Zoom, or just raise your hand or something, and then we can talk about them in the group. Just to give you a brief, I pushed a new fix on Git, so just make sure that you're pulling that branch again, because there was an issue where a force unwrap was actually happening, and now it's not happening anymore because I did a little, I had a little problem with the logic of how which view you show whether you're logged in or not. So just make sure to just pull once again, and then you get a working version. Because it could be that the error is just because of what you have previously built, but if you try now to build it, then maybe it builds fine.
I haven't tried to build anything. I just pulled down y'all's repo.
Just try to run the application once, and maybe that resolves the problem already.
Oh, yeah.
Yeah, perfect.
Huh. Okay. I'm not.
It was just some Xcode error still being present because of some reason. I don't know.
Okay.
But it should be building fine as long as you click build once. And sometimes you also need to close Xcode once and then open it up again, because it still has some old state somewhere.
Okay. All right. Sorry about that.
No worries. Are there any other issues from anyone else? Is there something that you would like to discuss about the Redux architecture, or something in general that you would like to say now? I'm talking to anyone, by the way. Okay. Yes. Hi, Rob.
Hey, is my audio now up?
Yes,
my audio is good now. Great. So I've been trying to apply Redux to the reload view. I started with the repositories view.
Mm-hmm.
Is it expected that we would need to rewrite reload view?
No, you can just get rid of the reload view, and instead, like, if you take a look at the reload view, then it's essentially just like it uses some method to create the view, and it's calling this on appear afterwards. And if you just replace the on, like if you just use the state from your app state to create that content view, then you can write up. Wait a second, I will send you a Slack code snippet.
Yeah, I mean, I've been able to do it. I was able to hard code it with a when, using your when, but then I wound up I'm particularly trying to capture this loading piece, right? I don't want to reproduce that in every.
Okay, so essentially in Redux, you would put the reloading part inside of the store and the reducer. So in general, you, instead of using that reload view, you would create that view from the state, and then on appear you would then call the action in the store, so that the store then reloads that state and actually changes your content view again. So as the first step, you would add to the app state whatever you require in your view.
Yeah.
And then you would also add an app action for reloading that data, or for loading that data initially.
Yep.
And in your reducer, you would then do the model action, like whatever is written inside that reload view at the moment.
It feels though like then the store is starting to pick up, you know, specialized. This one store has to know about every view in the system, which seems backwards.
No, it needs to know about everything from the model side, yes. And the views
but I want to know, do I display, what I mean is, where do I put this concept of display loading?
Yeah, you would need to write something like, okay, if the list is empty, or if my state is nil, like for example, you can make that list of pull requests or whichever view you're currently in. For example, you can make that array an optional, or you can add some state which has some kind of an error message or something like that. And depending on that, and depending on that state, you would then change the UI. But for now, you can just assume that there are no errors and no loading and stuff like that involved.
I know, but dealing with the errors is like the whole thing. All architectures are easy if we ignore the errors.
Yeah, that's obviously true. But,
I mean, I don't need an architecture if I can ignore the errors.
Sure, for now we want to keep the examples small.
I know. Yeah, so that's the thing.
So that
okay.
you can actually compare them. Of course, errors are like hard, and you actually need to capture them somewhere. However, in this case, you would essentially add a new property to your state to handle these kinds of errors. And in there, you either already have some kind of a string that you want to display to the user, that's something fake, or you just have some different state that tells the user that it's incomplete or like somewhat erroneous data.
And that's where I guess my question is, when doing it this way, I've only used Redux like one time in when writing stuff for Vue.js and using whatever Nuxt, that world. So I've done just a little tiny bit of it. But I guess my question is, it feels like you wind up with your app state growing and growing and growing and having lots of view specific information in it. I mean, like something for every view.
We're essentially getting at the moment.
Okay.
We are getting more in depth about that part.
Cool.
In like the next section.
I am patient.
And in the end, I'm happy to discuss this all when we've also talked about MVVM, the next architecture that we're talking about. And once we've introduced that one as well, we can we could just continue with that discussion, because then we have a full picture about the different architectures.
Awesome.
Perfect.
Thank you.
Does anyone else want to add anything? Otherwise, we would now continue to the next part of the presentation. Anyone? All right. No, it was wrong. Okay. Then I would continue with the rest of the part and hand over to Nazir for that. Wait a second before you turn it. So, I'm back. Let's start with the same thing that we did for. So let's discuss the metrics for Redux. Since we have a shared state, like one application-wide state, so it's really easy to maintain the consistency of the state. As far as the flexibility in the app is concerned, since like everything is done by the store, so
and almost all the views basically take a reference to the store. So you can move them around without even worrying about like the store not being available at other parts of the application. So it's like really flexible inside the app, because everything like the logic is inside the store. So the view are just like they're doing just the presentation part. Now the yellow parts like testability, as it can go both into the green as well as the red. Like if you want to maybe test this reducer or the state machine or maybe the whole app, I think it's easier to test it, because like if you, and even if you test just this reducer or this like the store thing, you have like tested a lot of almost all of the business logic. But if you want to test really like individual components, you will need to maybe make sure the store is storage and the reducers are in the right state. And I think it's not as easy. There might be a lot of like maybe you need to mock a lot of states to make sure you get into the right state for the view. The core overhead is, of course, you have to write all the reducers and store and everything else. So there is at least some code overhead involved, or maybe a lot, for depending on the type of application. If it's just like a 2 screens application, I think the code overhead is very much, but maybe for large applications, these 2-3 extra files or a few hundred lines of code is not a big deal. So that's why it can go both in the red and the green part. And the code consistency, it is like, since everything is inside the store, like the views are just doing the view part, and I think it also can go both, like it can go right as well as wrong, depending on how you basically design it. And the flexibility across the apps, if you have all the actions available in all the states that you want to reuse in other apps, then it might be really easier to move it across apps. But if the app has like it's a non-Redux based app, it's really difficult, because then you'll have to write all this overhead code and stuff like that. The code proximity, it is like, I would say, it can also go into this yellow part, because all the actions are in the store, but the thing is, if you think of from the point of view of the view, it might be that like you have to move quite a lot and need to know all these components that things are passing through, especially the store, to get an idea of what's happening. So in that case, that's why we put this in as a disadvantage. And the modularity is that I wouldn't say that there is a huge cohesion in the app, because like the store is doing everything. So it means that the store is a component with a huge coupling, like it's basically coupled to everything. So that's why we don't think like it has a good modularity. So these were the Redux architecture based like view comparison of the Redux based on the metrics that we defined initially. We will also talk about the metrics that you shared with us at the end, and try to put these architectures based on those metrics. And now, since we are now moving to the last part of the workshop, the view state MVVM, we basically started with a very basic model view. And if you search through the internet, you will find a lot of examples using that approach. Then we tried to abstract the state somehow at one place. So we went to Redux, and now we would like to have like much like better abstraction, and maybe like a lot of different types of states for different type of views. So the view state MVVM, as it says, that there are like the name says there are 3 components. We already saw the view and the model like in a lot of places. And in Redux there was a state, but now it's like we call it the view model here. And so the view model basically has a state as well as an input. So the views can pass basically input. So the view model basically can change the models based on the user input, and it also listens to the changes in the model. And the view can basically, so the view model is responsible for propagating the user inputs from the view to the model and make changes there. And it also basically provides like keeps the view up to date based on the state. Another example, and normally we always like try to have one view model per view, but it doesn't mean that like that view model cannot be reused for other views. So the idea in this whole architecture is this view model is that there could be like one view model can be reused for a number of views that are doing like maybe doing similar job or they're needing similar inputs or states. So another way of presenting this whole flow is that the view triggers input on the view model, which basically performs an action on the state, and any change in the state is basically propagated back to the UI, to the view itself. So now let's quickly go through how we can basically think of implementing this. So the first step is that due to a reason that I will explain while coding, we basically create a view model base with two generic types, input and state. As I discussed in the previous slide, that like the view model has an input as well as a state. So we define a base view model with an input and a state, such as like so. And it's an observable object because we would like to, like the view would like to listen to any changes on the view model. It has a published state, like as we discussed in the previous, in the SwiftUI introduction, like the one slide where we discussed what the publish is. So the publish is basically to propagate any changes to the state to whoever is listening to the view model. It's just like a very basic implementation. It has a state, and we basically, this is since this is like the base class, we basically don't implement the trigger so that any child view model that's needs to implement that method. So just it went really fast. Let me go ahead. Yeah. So the base view model doesn't implement this trigger method so that like we are sure that every view model basically creates it. And then the second step is basically to create like concrete implementations. You can have different implementation of the view model with the same type of input and a state. And that's like basically the whole idea of this architecture, that you can basically reuse or you can have like different implementations of the same type of input and state for different features. And the third step is basically more important, that you need to think about, like, since it's not Redux, you don't have one place where you throw in all the states. So you really need to think about what will the state be for this view model, what will be the input or inputs, and then the input is basically actions that the view model can perform on the state. So these three are the things you normally think, okay, what input should it have? What effect will that input have on the state, or what action will it perform? And what are the states? So, and then the last part is injecting the view model into the view so that the view can use it. And this is like, I wouldn't call it a step, but it's more like then using the view model in the view. Yeah, so I think it was super easy. Let's go to the implementation part. We take the Redux, like we have a Redux solution. It's the right branch. Let me make sure I'm in the right branch. Yeah. So you start with the Redux start, but we also have a Redux solution branch in there. And I think it's a really good idea to now try to make this store into smaller states and more local states. So I will start with this. So as you can see, we have the store and the store app and like everything that the Redux implementation has. So the first idea is to create my view model class. With input and state, and it is observable. And then it has a state. And it also takes input and as we discussed, that this isn't supposed to be implement. This is supposed to be basically implemented by the children. Okay. Since it's a class, I have to, oh yeah. We will take questions, or maybe let's just take it. Can you, there is a raised hand. Yes. There's a participant. Oh, there was a raised hand, but there is not anymore. Okay. I think the raised hand is gone, so I will continue. Sorry, I wasn't sharing my screen. The wrong screen was there all the times. I think you can see my screen now.
Yep.
Okay, so let me quickly recap what I did. So what I did was I basically create a view model with an input and a state, made it an observable object because we want to listen to changes on the state in the view. Then I added a published variable state so that like any changes to the state are propagated to whoever is listening to it. And since it's an observable object, so any changes to the state are basically propagated to any object of the view model. And an initializer, since it's a class, we need an initializer for it. And the trigger is, we saw in the slides that we want the children to implement this, so we make sure that we have an assertion failure. So any child that forgets to implement and use it gets like a debug time crash. So now we can start. I think a good view to start is basically the home view. So I would basically, let's quickly create a group. Just some organizational stuff. And let's create a home view model. So it's class home view model. Let's just implement it and we make it a view model. But now, before that, let me quickly create the, So let's quickly create the inputs and just, since we're using, let's go with the same thing that we previously used in enum. And then let's create a struct state just for the sake of simplicity. So it's home view model, model.input, home view model.state. Yeah. And since, let's not forget the trigger method, for now I will just switch on the input. Until now, everything is good. So now, let's go and try to implement this. So we have this store, or we have the home view. Where's my home view? So let's create an observed object in here, since we want to, we would like to basically remove the store at the very end, because if I remove the store now, then I have to change everything. So we go one view at a time. So let's keep the store for now. And we create a view model, which is basically a view model of time home view model dot input and home view model dot state. I didn't create a specific like a home view model in here because I would like to accept any type of view model that follows, that has this input and this state. So you can easily swap a mock view model and do your testing or anything else, or maybe you can switch it for different scenario. You want to provide a different view model, but if I do home view model here, then it means that I need to like provide either the home view model or any of its children, but this basically gives me a lot of flexibility in here. Now, see, so it says that I am missing a parameter. So now the question is, when is this home view model supposed to be created? So if we go to the store, since at the end of like this implementation, when we have a solution, complete solution for this MVVM, the store is supposed to go away, but maybe with the remaining functionality is supposed to be replaced with a login view model. So for now, since I'm keeping the store, I would like to make use of it and then say, okay, let's create a home view model here. Since I don't have a login view model, so I cannot keep this in there. So the store is currently the place doing the login. So let's keep a similar thing that we did previously. An optional since we don't have it initially. And now when do I create it? Basically in here, whenever I log in. So let's just quickly do like this and GitHub service. Oh, I did change the wrong thing. So here, and then I can create the home view. Wasn't it home view? Home view model equal. Basically, I can pass an implementation here. Or I can, for now, I can either pass an empty state. Now, the idea of this home view model is that now we want to move all the home related states and methods to this one place. So let's look at the store itself and see which methods can go. So we do a logout from there, and we also load a profile view. We also reload repositories, but since I will be implementing this part, just only the profile view part in here. So the two things that I need are these two. Let's just copy them here. And now, so if I paste them here, now I know which cases do I have. I have a logout and I have a reload profile. So I have got the state, and the other thing that I need is, as you can see here, there's a profile needed for the profile view. And if I remember correctly, this is more like an optional profile. So I will just say profile, optional. Now, in order to load the profile, I need the GitHub service. So let's provide this with a GitHub service. Since it's the class, as usual, we need to provide the so then
we need to set it.
Yeah, just a second. So for now, I'm just commenting this out. Let's go there for the next and just maybe to satisfy my obsession compulsiveness with this thing. So now I know I have a service. I don't care much about this. In here, it's yeah, in here. So now I have a GitHub service.fetch profile. I don't need to map anything because I want to use the data. So I just sync. And I say self.state.profile equal profile. I don't need the map here. And then since it's a sync, I need to keep a list of cancellables. I need to import combine as uses. So I need to have a set of cancellables. Let's just create one, and then I can say dot store in and cancelable. Now it should still not work because sync is expecting a never error. So we could just, for the sake of simplicity, and I think maybe Rob doesn't like it, but we just ignore failure for now for the sake of the demo, and we should be fine. Okay, yeah, the name, yeah, like this. Oh, what's wrong with this?
You need to put super.init with the
initial state. So now let's do a super.init with just initial state, which is null. Okay, so now we have a view model with the reload profile only. What to do with this logout? And since we haven't gotten rid of the store yet, and the logout is supposed to be performed on ideally a logout view or login view model, but that's the store for now, so we keep a reference to the store. Is it store? Yeah. And then we basically say store. We don't want to have the cyclical reference, so we just keep an unknown reference. And what we do here, same thing, we don't, so we say store.send.logout. So far our view model is good, but we have other errors that we need to take care of. The first thing is here, we don't need to provide the state at all. We need to provide a store, but we don't have access to a store here. So let's do a quick workaround and provide a store here, as well as here, because these two are the places where I need to create the view model. And then I can say store let, so I can provide a store. And now I just will do a quick, because so far so good. I think we can do the same thing here, because exact same thing. Okay, no, store is the second. The store is the first, so let's just move it around. So until here, okay, this seems to be fine. Okay, we come to this later. So we need to provide the store here. Is it store? Let's see, store login of store. Since we now provide a store, labeled store. I think there is one more place which also requires a store. That's now it's time to get the. Now the home view takes so the home view is currently taking a store as well as a view model. So we already have a store here, and then we can say .home store.state.home view model. Let's just force unwrap this thing, and I think we should be good to go. Let's try. Seems like we are good to go. We had the profile view. We kept the store in there because every other view is using the store. So if I start changing it, I have to do it in all applications. So we just took one view and tried to basically partially, since the home view is also like having this repository view, but we still pass the store in there. One option would be to use the store from the view model and then remove it later on. But in this case, it guarantees that we don't need to make any other changes. And so the ideal final solution would be that there is no store in the application, and the home view model is basically triggering the logout method from a login view model or a starting view model or whatever you want to name it. But that view model that handles the login, logout, and things like that. Okay, so I think we can open for some questions if somebody has some questions, or we can then move to the normal parts that we do, the exercise.
If anyone has a question, please raise your hand or write it. Oh.
Is it resting?
Do you still have the audio echo? Because the audio echo should be done by now, right? I forgot about that, sorry. Okay.
Okay, perfect. So any questions, or you can then start with the We have a repo MVVM start, which is basically the completion of Redux and then whatever I did now. So you can now carry on and maybe implement any other view model and maybe do this whole app in the view model.
Okay, everyone. So I would continue with the slides. However, in case you're not ready yet with the exercise, or you still want to experiment, just take a break for a second, and then we will just announce some, like we will discuss the different architectures for a short time, and after that we want to go into an open discussion with you. So you are it's still fine that if you want, you can then ask questions about the different architectures or discuss with us which architecture works best for you. So just take a pause from your development time, and then afterwards you can just continue with the exercises or take a look at the different solutions and stuff like that. And yes, and then we can still, like, even if you have questions to the Redux exercise or to the application in general, we can still answer your questions then. So let's take a look at the different metrics for MVVM. We can see that at least what we found is that testability is quite high for MVVM, because you can test individual views, you can test individual view models. You could even, for example, mock a view model and then just check out the view. You have a high flexibility across different apps, because you can just use that view with that view model and put it in some other app, and you just need to make sure to create that view model at some point. But everything originating from that view model should be pretty fine to be used in a different app. Modularity is also quite high, because we have the business logic in the view model, the user interface code in the view, and everything that is related to the model inside of some services, for example. Then going on to the medium part, we have medium state consistency, because, for example, we might have different view models that have a shared state, because they, for example, require some information that should be available throughout the whole app. Then it's quite hard to get that state to all of the view models, because synchronizing state between those view models, or even like providing access to the other view model, is not that easy, and there needs to be some kind of a workaround or a generic solution inside your app to allow for that state consistency. There is a medium code consistency, because all of your view models have like a shared structure, but it doesn't necessarily need to be super consistent throughout all of your view models. However, it's way better than Redux already, in the model view one especially. Code proximity is also medium, because yes, the code is closer to the view, and you, in comparison to Redux, because in Redux you would have to search for all of the different action cases to find the one that your view actually triggered. And for MVVM, you only have to check for one of maybe 10 different actions. But it's still different files that you need to have a look at, and you still need to create somewhat of an overview that you would not have with model view, where you have everything in one file. You also have flexibility inside the app, because you can move the view with its view model somewhere else. However, if you still need to make sure to create that view model at some point. So if you don't have all of the necessary information to create that view model at the other place where you want to put your view, then you would still need to change their like parent view models or something like that to allow for this flexibility. Of course, the worst part about MVVM is code overhead, because you have to write all of those different view models, and possibly if you want to make a small change, then it might also not be super easy to like have a different to change its implementation for a really small part. For example, then you would need to create a separate view model, but in general, that code overhead, in my opinion, is manageable for like larger applications. For a small application, it might not make sense to create view models for each individual view. However, then you can just say, okay, I want one view model for 5 or 6 different views, and that's then shared. In comparison to Redux, where you normally would only have one store throughout the whole app, for MVVM, you can have essentially multiple stores throughout the app, which are then called view models. So in general, let's recap. What did we actually learn, and how can we continue from here? And what did the workshop actually gain you as an experience, or as something to take away from this? So first of all, we started with the model view architecture, where there are multiple views and they interact with the model, each individually. Then we changed that to a Redux architecture, where you have a store that accesses the model, and each and every individual view accesses state from that store and also triggers action on that store. And then we even abstracted the app even more into view models for each individual view. We have now a separate view model, which then communicates, where then each individual view model communicates with the model. Taken from all of the different metrics, how they compare to each architecture, we gained the experience that the model view architecture is best for smaller apps or prototyping, something where you want to have a quick and dirty solution or something like that, where you just want to get on with something, and you want to, for example, show a view to a client or something like that. Then the Redux architecture makes sense for smaller apps which need to be flexible, where you need to be able to move a view from one place to the other without actually caring much about it. However, the apps should also be quite small, so that the store doesn't blow up to infinity, essentially. And then MVVM makes more sense for medium and larger apps, where you have a lot of heterogeneous features. For example, in our case, you have this repository view and you have the profile view, and those all connect to the GitHub service in some way, but they are heterogeneous from their actual appearance. Like, it's not different screens for pretty much the same feature or something like that. So that would be our take for the different architectures. However, we would like to get your opinion as well, and get like some feedback on what you thought about the workshop in general, and also what you think about the different architectures and how you would include them in your application, or how you would not include them. So thank you for listening. You made it through, and we will now go into an open discussion, or like we will. Yes, and what we also missed is the metrics from the audience, so we will just announce them for a second. I just need to reload Keynote for that. Let me get back to you. Okay, so we have made a list of the different metrics that we heard from you already. One of the metrics is the architecture resistant to Apple code changes and bug fixes. In our opinion, that is quite difficult to answer for the different architectures. In my experience, it worked like the less buggy version of SwiftUI is when you're using the model view architecture with a lot of state and binding. because that's what Apple uses in all of their tutorials. However, it's hard, for example, in larger apps, it's really hard to justify that kind of an architecture, in my opinion. So it makes a lot more sense to create some kind of a view model or some kind of a store concept into your app. So you will have those problems, and we just hope that Apple fixes them at some point. Then for code readability, in my opinion, it's the easiest, the MVVM approach, because you can, you only have a reduced scope of what kind of actions you have per view model, and you can easily find out which actions are actually connected to the view by just looking through this small flow of views, maybe like 5-6 views and one view model, and then you can easily get to where you want that data. Yes, for performance issues, I'm not entirely, as I already said, I'm not entirely sure how to answer that, because the different architectures that we presented do not really differ in performance. However, if you have a different opinion, or if there's anything that you would like to add for that performance metrics, I'm open for any kind of discussion. And the last one would be, how flexible is the architecture if we have a multi-platform app, or if we connect it to a server? I would argue that there probably the Redux architecture is the most flexible one, because you can easily, for example, if you build those multi-platform apps and you maybe have to change something because it fits like that kind of UI fits that platform the best, even though you started with a different architecture because it came from, let's say, a Windows application or a Mac application or something like that, then you easily have the flexibility to just move views around. However, it depends on the use case in general, in my opinion. Yes.
I would just like to add to this code readability. I think model view, in my opinion, is more readable than MVVM, because you have one file. Like as I remember, the question was more about if I can find things in one place and how the jumps are less. So I think view model has one more jump, but overall understanding, once you get to know this view model, how you have a view model for a view, I think view model, the MVVM becomes a little bit easier. But I think if you just think about the code proximity or readability, I think in the model view you get everything at one place, and you don't need to worry about jumping to places. But one metric that I normally like is that how easy is it to change code. So if you have a good readability in the model view, and you have the same operation like the logout in 5 places, and then you forget to change in one place. So I think it all depends on which type of metric you have, so which is more important to you. But I think for me, the code readability is, I think, much more in model view, but I think it really breaks a lot of other good metric that we would like to have in our larger apps.
I would actually like to argue about that, because in your view, you then have code that is somewhat unrelated to each other. And to find the code that is yes, the code is quite close to each other. However, your views might blow it up a lot. And then you cannot really find which action, for example, is performed by which kind of a button or slider or some other user input. So it's quite difficult to then decide where the code is actually located and which parts are actually connected or not connected.
Yeah, but in that case, the view model also, if it's such a large view, it's the same thing for view model. Your view model is going to blow it up as well. So it's all about how you design it as a whole. You can also have even we can mess up the really good metric for the view model like MVVM if we don't design it the right way. So I think at the end, maybe a combination of Redux and MVVM might be a good solution for some cases where you have some shared state across and some local state. Like it's all dependent on your, I would say, your requirements and which metric is much important to you. So you can always like following one metric sometimes like breaks other metrics. We can open the discussion.
Okay, thank you so far for listening. From our side, the workshop is pretty much closed. However, if you have any questions, if you want to discuss it with us, if you just want to point an opinion, state your opinion about the different architectures, or just in general open a discussion about SwiftUI, feel free to just raise your hand or write something in Slack. And otherwise, yes, we will probably leave the Zoom call at, what is it?
In 20 minutes almost.
In 20 minutes or something, but until then, feel free to discuss with us whatever is on your mind.
Okay, fine. Fair enough.
Yeah.
He's like, you kept talking. Yeah. So the thing that really struck me, though, is how these three specific, I mean, these architectures are all about managing state, as opposed to other things such as navigation. And what's interesting is they really kind of played into each other very nicely. I mean, you're actually showing, I think, a lot of great examples of, hey, I have a program that's already works this way, but I can refactor bits of it, but not all of it, to work in other ways. I think that really is showing, that there is this kind of Redux sense. Some things are global state, they're kind of the whole world. There's some things that really are view state, the idea that the individually current selection would be global state seemed weird. So saying, okay, I'm going to pull that into a view model, makes a lot of sense. But then again, certain things like where the cursor is right this minute, or what text is in the text field, in a lot of ways, that does feel like local state. So I think the point being, these don't in any way feel exclusionary. They feel like just different parts of one giant approach.
True, you can easily just swap them out. Or, for example, you could easily have the MVVM approach. However, you could have like a base view model that is available in all of the views, which would then be similar to Redux.
Where you have particularly, I'm always thinking about things like who is the current user, the big global things. The usual problem that I've been having building SwiftUI apps, and that but I still haven't seen how this would help me, is navigation. It's like I'm 6 pages deep, but now the user has been forcibly logged out, and I need to pop them all the way to the top.
Yes, but you can do that by just essentially, since SwiftUI works as a function of state, you only need to change the state, and then the navigation is already done by SwiftUI.
And I do use that too, and I'm doing that now by passing around a selector that says that anybody can set it to nil, and that'll pop me out. But the idea of doing that through a Redux kind of global app state of rather than navigating on your own, you would constantly navigate by assigning things to, by doing actions on Redux. My only question is whether that actually works with SwiftUI today, because of how they have navigation links. That there's so many things in SwiftUI where it works one very specific way and you can't touch it.
In the MVVM solution, we actually have an example of where we use navigation links, and we still we use the navigation link as kind of a button to set the state.
Yeah. Yes. I have done that too.
No, so essentially, it is what you like for a navigation link. You can, for example, also specify a binding of bool, where you can specify whether that navigation link is active or not.
Right. Well, and actually, the one that I'm using more often is you can have a binding to a selector, and then you can tag. It's actually a string. You can make a string.
Okay. Yeah.
And then you can tag throughout your whole app. You can actually tag navigation links with that string. And so you can actually navigate to arbitrary parts of your program using that.
Is that
and I've been
added in
exploring
iOS 14 or is it already present in iOS 13?
That's in 13.
Okay. Crazy.
Yeah, look at navigation link. It's like selector. I'm using that a bit right now to try to. This, though, gets to my earlier point in terms of when we're thinking about architectures and how they interact with Apple. If you came up with something that seemed really clever, like using navigation links in a way that doesn't really navigate, those are the kinds of things, and you figured out a way that it kind of worked. That's the kind of architecture that scares me, because that's the kind of architecture that the next version breaks. It's like, it works technically, but
technically, but actually it doesn't look like it would be working.
Like you're getting away with it. Yeah. Anyway, that's a great talk, by the way. I really, really love that.
Thank you.
Thank you.
Paula asked in Slack about, does the coordinator pattern plus MVVM make sense? And I thought about that a lot, especially because we developed a coordinator pattern library for UIKit. And I actually tried to build something with SwiftUI out of it. However, I figured that since SwiftUI is this, the view is a function of the state to some user interface, I find it quite hard to then define a coordinator pattern that would not be pretty much the same as MVVM, because in the end you cannot really trigger any transitions or something like that would not result in some kind of a state change. So in the end, your coordinator would also be kind of a view model. So in my opinion, the coordinator pattern plus MVVM is quite similar to just having another view model only handling the transitions or something like that. But in the end, MVVM also already kind of includes the coordinator pattern in SwiftUI, if that makes sense. Especially because your view defines all of the transitions, so you cannot really extract the transition logic from the views. So in the end, it's just the view deciding however it looks like. And a coordinator pattern would then look either something like, okay, I'm setting a state so that the view can react to it, or you have a view that is only handling all of the modal presentations, all of the navigation links, and something like that. And I have actually thought about that, but both of them do not really compare to the coordinator pattern as it is used in UIKit. I hope that answered the question as much as possible.
We still have around 10 minutes, so if anybody else wants to share his opinion on anything in the workshop, feel free.
Thanks, Rob, for the link. I will check it out. Yes, it is recorded at the moment. However, we are not entirely sure whether it's going to be uploaded as it is, or if there's any post-production happening. We will let you know about that in the coming days, or once we have new information about it.
So a question was about MVI. We haven't used much MVI, but as far as I know, MVI is more like the view is based on the state. But I think in the MVVM, it's not necessarily that like the view is using like all parts of the state, or maybe like my experience or the Android devs that I normally work with, they have that like every time there's a change, like the view is supposed to be reloaded. So it's like really closely linked with the view itself. But in this, like you can also have a view model with a void state. So it doesn't even, maybe the view has no state at all. And I think, I'm not sure if that's possible in MVI, but we have like honestly not that even a very basic knowledge of MVI, so maybe we are not able to answer this question in a satisfactory way.
Ash, I'm not entirely familiar with MVI, not at all. However, your explanation of MVI equals MVVM plus channel plus reducer plus immutable chain state somehow sounds like you would simply be doing our Redux approach just by also using multiple stores throughout the app. Am I understanding that correctly, or is there anything else that I need to know about?
Is there one immutable state per view model, or is it a one immutable state for the whole app?
We just set you so that you can, so that you are permitted to talk if you want, but we can also do it via Slack, whatever suits you best or whatever you prefer. The immutable state means that the views cannot really change the state, but instead they have a read-only state that can only be changed by reducers, right? Okay. In general, the immutable state is somewhat difficult with SwiftUI since you have a lot of bindings, for example, that change the state, and for example, sheets are also based on because the view itself can decide when to because the view itself can decide when it's going to be dismissed, for example, by this pull down mechanism. It's quite hard to make use of an immutable state that is truly immutable. However, if you take a look at the Redux implementation, then the state is mutable, but it's not intended to be mutated by anything else than the ones that SwiftUI uses itself. And of course, you could also build your own bindings that in the setter would just send an action to some view model or something like that. That's also possible. I'm not entirely sure whether that's working, because of SwiftUI bugs and similar things. Yeah, it's technically possible. However, I'm not sure whether that's adding a lot. Especially for state that is subject to constant state change, for example, a text field or something like that. There, it might not really make sense to have this whole reducer thing going on, because the actual reducing of your action to a model change will probably take too long for the text field to update in time. So it will probably create some kind of UI bug all the time, which then makes more sense to have either local state, which you're then propagating whenever you have a button tapped or something like that. But otherwise, I would not suggest to have the immutable state that is truly immutable and only can be changed by reducers. But in general, if you take our Redux approach, it would be quite similar to that. Are there any other questions regarding MVI or regarding any SwiftUI architecture or the workshop in general?